So good morning to all of you. I welcome you all on the second day of this online FDP, sponsored by AICT ATAL Academy on Internet of Things and organized by Institute of Engineering Technology, Dr. Bhimrao Ambedkar University, Agra. So the first session for today's is on embedded systems for IoT applications. And it will be delivered by eminent speaker, Professor D.N. Sonawane sir, from College of Engineering, Pune. So I would like to just give a brief introduction of today's eminent speaker, Professor D.N. Sonawane sir. So Professor D.N. Sonawane sir is currently an associate professor and head of Department of Instrumentation and Control at College of Engineering, Pune. He has over 23 years of academic and research experience. He is leading a research group mainly working on optimization-based control, embedded optimization, and real-time embedded applications of model predictive control. His research interests include embedded control and optimization-based control. And as I said, he's leading the research group in the area of MPC, embedded MPC, and development of embedded real-time applications with MPC. His research also involves mathematical modeling and optimal control of Li-ion batteries and battery management systems. And also he is involved in development of energy efficient controller for BLDC drive and its applicability to electric vehicles. He is head of the department of instrumentation and control since 2019, and he also was a visiting associate professor at University of Washington, Seattle, from June to July 2017, as well as in 2018. He's a postdoctoral research associate at Washington University in St. Louis, USA, and University of Washington, Seattle, USA, during 2014 to 16. And he's working as associate professor since 2008, and he worked as assistant professor at the same college during 2005 to 2008, and he has worked as a lecturer in the Department of Instrumentation and Control, College of Engineering, Pune, in between 1998 to 2005. His education, he has done his BE in Instrumentation and Control in 1998 from University of Aurangabad. He's done his ME in Electronics and Telecommunication in 2000 from University of Pune, and he did his PhD in embedded implementation of model predictive control in 2012 from University of Pune. Some of his research projects includes numerical optimization in reconfigurable hardware to extend the use of model predictive control for real-time applications. It is ongoing project. The another one is design and development of signal processing unit for proximity sensor, sponsored by DRDO, ARDE, Pune. And then some of the other are development of sensor and data acquisition, remote triggered virtual lab and initiative of Government of India, as we all know, through ICT scheme. He has completed that in between 2011 to 2014. And then development of FPGA embedded system, virtual lab. This one also completed in between 2010 to 2013. Then subcutaneous vein detection system for drug delivery assistance. It was a UGC major research project scheme, and it is also a completed project in between 2011 to 2014. Then VLSI implementation of DSP for model predictive controller. It was a AICT research project scheme, okay, completed in 2008 to 2010. And he has also done some industry sponsored projects energy optimization of battery operated emergency light system for railway coach, Intra Electronics, Pune. The product was RDSO approved and later commercialized. It is also completed in between 2010 to 2011. Then microcontroller based development of flow indicator for UV based water disinfectant system, UV microsystem Pune. It is also completed. He has published more than 10 journals and more than 30 conferences, and he has also published one book. And he has also published a USA patent on robust fail safe iteration free approach for solving index 1 DAEs arising from battery models. And some of the awards which sir has achieved, the one is visiting associate professor at Department of Chemical Engineering, University of Washington, Seattle, USA, recipient of Duo India Faculty Exchange Fellowship for faculty exchange in summer 2021 with Professor Sorin Olru of Central Supélec University, Paris in France, a recipient of Unicorn Innovation Award in 2012, Best Paper Award at CCPE 2012, National Level Award. He has achieved OMA Indian Annual Challenge in 2010. It was the first prize. Then sir has achieved certified trainer of Microchip Corporation USA. Sir is also a reviewer of IEEE transaction on computers. And also sir is a reviewer of InterScience Journal of Circuit and Architecture Design. And sir is also chairman of IIT Pune for the year 2020. So we welcome you, sir, for your lecture in this FDP.
Yeah, thank you. Thank you, Professor Naman, for the long introduction. So, yeah. So, I welcome you all for this session. And thank you, organizer, for inviting me. This is one of the good initiative of Government of India, AICT. Through the ATAL lecture series, ATAL FDP, we at our department also recently conducted one FDP through this scheme, and it was a huge response across the country. And these are the participants I know. They are not only from your college, but these are from across the country. Because there is a common portal where you're supposed to register. So my today's talk is on embedded systems, specifically for the IoT applications. Is I audible, Naman?
Yes, sir, you are, sir. Yes, sir.
Okay. So hope I am clearly audible to all of you. I have been in this area from last 25 years, embedded systems, then importing the complex control algorithms on embedded systems. People always questions, what's the deal to implement the algorithm on embedded system? Nowadays, there are ready-made programs are available and ready-made functions are available. You just have to take the code, compile it, and put it on embedded system. So, yeah, it's for the sake it looks to be easy, but when there are a lot of challenges, you will come to know what are the embedded system challenges, and literally people get frustrated. So this is that even they knows how to write a program for small microcontrollers, but when you really actually go for porting the algorithm for real-time applications and running to the resource-constrained environment, that poses a big challenge for the designer, that poses big challenge for the programmer as well. So that's why it becomes a different side of research, and algorithm development, of course, this is another side of research. So let us start with this. Now I'm going to share my presentation, right?
Yes, sir. Yes, sir. I think you just click on share screen, so you will be able to.
So this is multiple participant can share simultaneously, right?
No, sir. No, sir. I'm making
one
you a host, so only you can.
Yeah, means there are options. Okay.
Yeah. Yes, your screen is visible now, sir.
Visible now, right?
Yes, sir. Yes, sir.
Okay. So hope this is visible, right?
Yes,
This
sir.
is
It is
now,
visible, sir.
it is visible, right?
Yes, sir. Yes, sir.
Okay, sounds good. Yeah, so today's talk is on embedded systems for IoT applications. I hope most of you faculty members, students, those are working in this area. So this is not a new topic to all of you, but I will take you some other way so that I hope in coming 1 hour, 1.5 hour, you will feel something new to be learned. Okay, let us start. This is my today's agenda. I'll first of all go with the basic fundamentals of embedded systems, what exactly embedded systems are. Then microcontrollers, those are integral part of these embedded systems application development. What we should be consider from the microcontroller. Then going to the application specific to Internet of Things. What is the specific requirement for the embedded system when it's going to be applied for the Internet of Things? The applications of Internet of Things, and there are some development boards are available in the market. So people should be aware about, are we going to be designed from the scratch, or there are ready-made solutions are available. We just have to pick up the solution, customize for the application, and let that solution will be ready for your application. So such kind of solutions are already available. I will just go through that. I will let you know which type of solutions are already available. Before going to this, and then I will let you know what exactly the future of IoT coming 5 years down the line, 10 years down the line, where people are looking for IoT. IoT, this word is coined very perfectly. This is not the very new word. This is not the very new concept. But last 10 years, 15 years, people are using this word, and now it turns to be some industry 4.0, machine learning and all these things. But then you will realize what are the relation of industry 4.0, machine learning, data science. Is there something different than IoT? That also I'm going to highlight on these points. And before going to exactly what is embedded system, I'll take quick 2-3 minutes. I'll show you some examples. So probably hope these examples is visible to you. Naman, please let me know if not visible.
It is,
It's visible, right?
yes, sir, yes, sir, it is visible as well as audible also.
Okay, great. So all the participants, please carefully observe this, what exactly is happening. Okay, so this is one application of where embedded system application, microcontroller application. I'll just go to another application. Okay, so I'm just stopping here. This is another application. Uh, every application has certain meaning to show you guys. I will ask you later on. This is one more application, and now I'm going to show you the last application. Maybe many of you have seen this application, which is available on the YouTube. See, one of the best example of the control system. I'm just taking forward. This is called as a drone, a quadcopter system, and it is a fully controlled quadcopter system. Have the interface of cameras. This is TED Talk. You can find out on the YouTube as well. And the professor who is going to explaining him is fully controlling that quadcopter. Even is giving some disturbances and everything. Probably I'll just take forward, and so you can realize. So this is fully stable in all circumstances. Even he is going to control through the joystick kind of thing. So how he moves the joystick, accordingly the quadcopter gets stabilized. So this video is available. You can visit later on this video. Yeah. So it's very interesting video. See, best example of control image processing is embedded into the embedded systems and the embedded application. How it is a best application to be designed. This is the best example of the embedded systems. Okay, so I'm going to stop here. Now, I hope all the 4 applications, all of you have seen very clearly. I'm going to ask you some questions based on this. There is some motive. That's why I have given motivating videos, the motive for showing these videos. So what is the common in all examples? So if you ask me what is the common in all examples, very quickly, if anybody can very unmute yourself and tell me what is the common in all examples.
One can write in the chat box as they are, I think, muted. So
Okay.
one can write in the chat box.
Yeah, even you can write in chat box so I can see that, right? What is the common in all examples? So any reply from you guys? Okay, no problem. I will let you know. So the common in all examples are they're using a microcontrollers. All applications are microcontroller based applications, and this is embedded system applications. This is a common in all example. But which microcontroller tools they are used? Are all the applications has only one microcontroller? Because applications are different. First application is simple counter. The person is just putting some hand in front of the IR sensor, and the counter is incrementing how many times that IR sensor crosses that hand. Accordingly, the counter is. These applications in malls and where you are just entering, your gate opens and your counter is there. So this is application. Second application was wire winding machine. There is some tension, is controlling some torque, such kind of application. A little bit control is there, not feedback control, but simple open loop control where torque is there, and it's a wire winding machine. Third application was where motor control kind of application, like there's a conveyor belts and escalators, such kind of applications where the speed control and torque control is there. And fourth application is really high-end embedded applications. So where image processing, control algorithm. So that's why all the 4 applications are different in complexity, different in nature. That poses the challenge of designer to choose the appropriate microcontroller. If the microcontroller which is using the 4th application can be used for all 3 applications, because that is a high-end microcontroller. But there is no point to use very advanced microcontroller just simple for counter application, where nothing is there, only 2-3 IO lines are used and just simple program to display on the counter. But the microcontroller which is using for the counter application cannot be get fit for the 4th application. So then it necessitates to study the application very well, accordingly to choose the microcontroller where exactly it suits, where exactly the requirement matches. Because in the market there is a n number of derivatives are available in the microcontroller. We should not be pick whatever I know, but we should be think of what is my requirement, and accordingly we should be choose. So then how to design an embedded system for an application? All these three questions are very important. They are really motivating for us to go ahead for learning what exactly mean by embedded systems and how to choose. See, embedded systems is not only writing the program, not only soldering and making the PCB, but the most important thing is embedded system. Like as an engineer point of view, if we're talking about choosing a right microcontroller for right application. So that is the most important thing, choosing a right microcontroller for right application. So let us start with little bit small intro about what exactly the embedded system is. So there are a lot of definition of embedded systems in the given in the book. Every book has different definition, but definitions are definitions. But what we understood of embedded system is very simple way. Define the complex things in a simple way. That is understanding basically. So the precise definition of embedded system is not easy to mention, but it's very simple way. What we understood is a computing system. Like all embedded systems are computing systems, digital as well as analog computing systems. Other than general purpose computer, all are embedded systems. So if you look for the laptop, if you look for the computer, if you just leave aside these two areas where laptop and computers, PCs are general purpose computers, but embedded systems are, except these two devices, all are embedded systems. Any application you take, this is embedded system. So this is the abstract view of embedded system. Have some inputs, have some outputs, give some energy, parallelly your heat is get generated. So every embedded system has some computation and it will generate. So this is the kind of abstract view. So at least you realize then anything which is doing computation other than laptop and general purpose computer are the embedded system. So imagine day-to-day life, we are coming across a lot of embedded applications. So it is a computing system rather than general purpose computer. It is embedded as a part of complete device that includes hardware as well as software. So embedded systems, not only hardware, it's a combination of both hardware and software. And embedded systems are managed by single or multiple processing. So maybe have one microcontroller, maybe have multiple microcontrollers. The example of multiple microcontrollers is your car. If you see the car, at least 20 to 30 microcontrollers are there. There is a one ECU, master ECU, and there are many sub ECUs. Those are communicating over CAN bus, and the master ECU is controlling the different ECUs. So this is an example of multiple cores. Maybe DSPs are get used, maybe FPGA, maybe ASICs, depending upon the application, depending upon the complexity. Accordingly, the computing platform is get used in embedded systems. And this is a typical example of embedded systems. So if you see that every embedded system has a CPU, means microcontroller. Now, if you see this is a straight line, of course, every embedded systems are working in real time. So it has the sensors, which is connected to microcontroller. And sensors, 90% sensors are analog in nature. That's why you require the ADC. Not necessarily every time you require ADC, some sensors are digital in nature, like encoders and proximity switches, and these are the digital in nature. So, but 99% sensors, because your data around you is analog in nature. That's why you require DAC as well, because all your actuators are analog in nature, motors, valves, most of the transistors and MOSFETs and all actuators are again analog in nature. That's why you require DAC. Not necessarily every time you require DAC again, but most of the time. So this is open loop kind of thing. Without sensor, without actuator, I don't think hardly there is embedded systems, but most of the time there are sensors and actuators are involved. Or there is some softwares as well. Of course, memory is an integral part of every embedded application. Your memory may not be sufficient for on-chip microcontroller, Then sometimes you are connecting external memory, flash, RAM, SD-RAM, SD card. So you are connecting, depending upon the complexity, you connect external memory. This software is the OS, maybe OS, may not be OS, maybe your custom application software is running. Of course, there is a human interface. Without human interface, again, your systems are very, you mean to say, not that intelligent kind of system. So human interface is there. You can have some push buttons, touch screens, some human interface, diagnosis systems, auxiliary systems. So all are again working together. So you take any example of embedded system. So that example fits into this diagram, and then you correlate. What is microcontroller in my application? What is sensor in my application? What are the actuators in my application? Which software is running? So whole combined together, that will become your embedded applications. Now application areas, everybody knows embedded systems are integral part of a day-to-day life, from smartphone to medical equipment, from microwave ovens to anti-lock braking systems. So variety of applications, automotive applications, household applications, so your consumer applications, from life critical application to security, your video phone, luxury to heavy duty applications, your JCBs and your excavators, from handheld gadgets to the huge control systems. So even your, wearable devices to the huge control systems. So your control system in the ships, control systems in aeroplane, control systems in railways. So all applications are embedded applications. So imagine if embedded system is integral part of, I could say simply, embedded systems are integral part of our day-to-day life. If you woke up early in the morning to the evening to the night, at least every person is going across hundred of embedded applications. So it demands, there is a lot of necessity of embedded engineers. There's a lot of necessity of embedded system developers. Now, see that the market of embedded systems. So inside most of the devices, from music player to the mobile phones to the car, trains, medical equipment, and so on, more than humans on the planet already. So these are the embedded devices. 40 billion of such devices by 2020. 40 billion, more than humans on the planet. 99% of processors used in embedded systems. So 4 billion embedded processors sold last year. This is data of 2019. 4 billion embedded processors sold. Every week, one microcontroller comes in market. Different microcontroller comes in market. 71 billion pound global market in 2018, and that growth is estimated for 14%. Market size is about 100 times the desktop market. So how much is the desktop and laptop market is there? So 100 times embedded system market is there. Now you just think on what is the demand? Where world is thinking of, everybody wants to miniaturize the thing. Everybody wants to miniaturize their application. Of course, that demands the embedded systems. So see, these are the applications, some snapshots I have kept for the applications. Our daily lives now depends on embedded systems. Every person in this class, see that from your home to your office, transportation, everywhere embedded systems are there. Then why should not learn the embedded system? Why should not understand the designing of embedded systems? So these are some products I just told you, the NASA Mars rovers. This is also best example of embedded systems, from big to the small, tiny pico satellite. This is also example of embedded systems. So then what are the characteristics if you look for the embedded systems are? Generally embedded systems are application specific. They have the single function and application is known to the priority. When if you thought of designing of embedded system, let's say I am a designer of embedded system. First of all, I should know the application for which I am going to design the embedded system. I should not like doing my laboratory experiment, going in my lab and picking some board and just putting some experiment, downloading some experiment and taking some output. It's not like that. I should understand the application very well. What is the application requirement? What is the timing requirement? What is the data requirement? Memory requirement? How many input outputs is required? How many sensors I want to interface? What could my actuator? What user is going to do? What is the customer requirement. So all these things comes to the understanding the application. So that's why whenever you're going to design your embedded system, eventually prototyping you are going to do, but eventually it will become very application specific. And of course, efficiency is a paramount important. All embedded systems are very efficient. Take example of your mobile phone. You see the mobile phone cost is around 10,000, 15,000 rupees. Your laptop cost is more than 25,000, 30,000 rupees. But people expect that my mobile phone should give the same performance like my laptop. Most of the applications. I'm watching the YouTube video on the laptop. I could not tolerate like my YouTube video cannot has a low quality on my mobile phone. Expecting that I should get the same quality. So then what is poses? It poses challenge on the designer. That's why application, apps and all these things come in picture. I could not run full software, then I can come to the abstract of the software that is an app, but my quality will remain same. Functionalities remain same. So because of the resource constraint, I poses some challenge for designer and designer come out some solution for apps. Like you could not surprise there is a MATLAB app will be there also. MATLAB is running on your mobile phone. As good as become like your computer. So efficiency is paramount importance for embedded system. They are optimized for energy. They are optimized for code size, execution time, weight, dimension, cost, everything. And the embedded systems are typically designed to meet real-time constraints. Every embedded systems are written in an infinite loop while one kind of application, so that we don't know what is going to be happen anytime. Like your best example is a washing machine. The designer has thought of that. Anytime any person can come and put and switch off the washing machine, press some button. So then it should be reactive kind of thing. So anytime, any moment, it should be sense some buttons are going to be pressed, then what should the action should be taken. It's a real time. So it's always operating in real time. It's not like that only time program is running and that's it. It's not. So infinite time your program is running. So every time it senses something going to be happen. So embedded systems are often interact with sense, manipulate, and communicate. These are the three main functions. Sense means it's take the data from sensor, it manipulates, converts analog to digital or even digital value, then calibrate it, convert to the specific format for display, or maybe they convert to the specific format, maybe given to the another function like generating PWM, controlling the your PWM. So manipulating your data and communicating, maybe wired communication, maybe wireless communication. So of course, communication, maybe local display, communicating via parallel on local display, communicating on serial, right? So communicate or maybe communicating at a long distance over Wi-Fi, wireless like that. So sense, manipulate and communicate, these are the major functions of embedded systems. So if you ask me in short, the embedded systems is a combination of both hardware and software. Of course, not only the hardware is sufficient to execute your application. Once you design your hardware, then you have to be write down the software which interact with your hardware and your application get developed. Hardware which is forms the body of an embedded system, while embedded processor which acts as a brain. Of course, all the intelligent task is done by embedded processor. And embedded software which forms its soul. It is the embedded software which primarily governs the functioning of the system. That's why every embedded application software has become very critical and software has a lot of importance. And that's necessary learning of embedded programming as well. So embedded programming learning is very important because if you see all these 3 points, you can get ready hardware, you can get even the help of the people to design hardware, but eventually you have to write a software. Even microcontroller is there, which is the brain of that product, brain of that embedded system. But to integrate to work with the application, you require a software to run. And that's why it's very important to learn the embedded programming. Now, what are the design approaches for embedded system? Assume that now you are going to design the embedded system. What approach you need to follow? So it's a combined hardware software approach. Why embedded system engineers has enormous importance? It's not only computer. If you ask me, the computer science engineers, they are very good in software programming. But how many people knows the embedded systems? Real, the registers and their memory map and SFRs, all these things. When you write a program for a particular microcontroller, you should know the hardware as well as how my transistor functions, how transistor act in a switch mode, how transistor act in a saturation mode, the how MOSFET functions. So these all are the your hardware. So that knowledge is equally important for embedded engineer. If you ask only electronics people, even they have very good knowledge of hardware, but parallelly you should have the knowledge of software as well, right in the software program. So the person who has both the knowledge together, hardware and software, that's why it comes as an embedded engineer. So embedded engineer is something different than conventional software engineer as well as conventional hardware engineer. Custom software that runs on the off-the-shelf embedded processor and generally design approaches where co-processor approach. Nowadays, co-processor approach is becoming more popular because a single microcontroller for little bit complicated applications I'm talking about. Small applications is okay. Your one microcontroller is enough to do the thing, but little bit complicated applications like your TV and your automotive. So such kind of applications where a lot of things are happening parallelly. Your video processing, your audio processing, your security, your internet, so many things happens parallelly in the smart TV, even in the car. So
First year
please, you can mute yourself, sir. So special processor with general purpose like DSPs, graphic processor, hardware accelerator. So these are the essential things to be interfaced with your host processor, because you could not load your host processor too much, and that will be again generating a lot of heat.
ఏది చెప్పండి మేడం ఆటోమొబైల్ చెప్పండి ఎన్ని ఉన్నాయా
18013
ఆటోమొబైల్ ఇంజనీరింగ్ 180
A049
049 ఒకటేనా మేడం నెక్స్ట్ ఏముంది మేడం
Hello.
ఏ అయిపోయింది హెచ్ అయిపోయింది హెచ్పిసి అన్నారా
Naman, is I'm audible?
హెచ్పిసి లేదు సివిల్ సెవెన్ సివిల్ సెట్ అయ్యగా 2 3 4 5 7 సెట్ అయ్యారు హెచ్పిసి ఫస్ట్ ఇయర్ మేడం వాడు అయిపోయింది అది సిఎం చూడండి మేడం సిఎం చెప్పండి మేడం
18030
CM
Is I'm audible, Naman? Okay. Yeah, please. I'm not getting exactly whether I'm audible or not. Yeah, okay. Okay, great. So, yeah, please let me know because it seems to be uncontrollable for my side. So these are the design approaches. Now you see the waterfall model. So when you are going to design the embedded system, so you should follow this particular approach. There's a design cycle. So in design cycle, first block comes to the requirement analysis. The application, what you are going to design, you are doing some requirement analysis for that. Then designing means if you fail to analyze the requirement of a particular application, you cannot properly design the application. So the requirement analysis is very, very important. Then comes to the specifications. When the customer has asked you to design, let's say a temperature scanner, this is one application you want to design, temperature scanner. You don't know for what purpose temperature scanner is. So you want to, whether it's for the industry application, whether it's for the human being, whether it's for the animals, or for what purpose exactly temperature scanner is going to design. What is the scan rate is required, whether it's a continuous scanning, whether it's a batch scanning. So all these things you should be understand first of all. What type of display you require? It's a local display or it's a remote display. Whether you want to transmit the data, whether you want to don't transmit the data. So all these analysis, once you are done this, then you come to the specification framing. And then you select the hardware, which microcontroller is enough, how many memories you require. Okay. Then start prototyping the thing, integrating the thing. And then in this way, have some a test a strategy of your application inside it. Of course, maintenance and everything will be part of that. So this is the way your embedded application get designed, and that's why it is called the well popular, a typical waterfall model of the described in the project life cycle. So any project what you are going to be work on should follow this life cycle. Then design consideration, once your prototyping is done, then in a final product you should be go and prefer the ASIC. So application specific ICs, it should be preferred. Now let's see where it's going to be used. ASIC generally get used where the mass production is there. It's not for one or two application. Let's say BTech project or MTech project are doing, students are doing some project. They could not go for use the ASICs. They can be used for prototyping microcontroller. And once the prototyping microcontroller is finalized, then you say that, oh, I require only 2 ADC channel. I require 10 IOs. I require 20 this pin, IO pins. So once your requirement analysis is freeze, then you can approach to ASIC designer and say that, can you design me the ASIC for this, where I'm going for the mass production. So all your applications like microwave oven, your washing machines and mobile phones, generally they use the ASIC and they prefer the ASIC. Because ASIC will give you the best cost, performance, power, energy, flexibility, maintainability, and of course size and time to market. So these are the major things that should be considered again while designing. Time to market. What is the importance for time to market? Let's say I am designing the temperature scanner. Nowadays, temperature scanners are very, very useful. It's a very hot product. You say now I have started designing temperature scanner, and suppose 1 year down the line my temperature scanner comes in market. Who is going to buy from you? Today there is a market. Maybe next month, 2 months down the line, there is a market for temperature scanner. After 1 year, this situation may not be there. So there is no value for your temperature scanner. Today you can sold temperature scanner for 3,000 rupees. After 1 year, nobody can buy you from 1,000 rupees. The time to market. So my product should be in the right time to the market, and accordingly you should think of, suppose I want to put the product in a very right time, then how to accelerate to design of my product. So time to market is very important. Size, like your wearable devices. Resource constraint, my size is like a watch, digital watch, small size. If I'm going for 8051, conventional 8051 and Raspberry Pi and this kind of microcontrollers, they are not even microcontrollers are not, microcontroller size itself is a watch size. How is going to fit there? I should think of something, different product, different microcontrollers, different sizes, packings, so that based on my requirement, based on my size is going to fit. Flexibility for the design. Today I have chosen some microcontroller. I should think of 5 years down the line, the same microcontroller, same tools, same support from the manufacturer should be available. Otherwise, I will end up in some situation where today my product is tested. Tomorrow when I'm going to commercialize, that microcontroller support has removed from the market. No use for that. So all these things are very important while design, and this is, I could say, most important factor when designer has to be considered. Another important parameter is like, there are very famous law called Moore's law. So the Moore's law says that, this is the Moore's law, processor complexity. Everybody knows that every year the transistor requirement, transistor inside the processor is becoming double. So the chip is reducing in size, the transistor is going to fit more and more. So this is the Moore's law says that. So, but You know Shannon's law. All the electronics guys know about this Shannon's law. This is called algorithm complexity. You see, this is the graph, the algorithm complexity and Moore's law. Now the delta is increasing. What does it mean? The customer requirement is increasing, algorithm complexity is increasing, your off-the-shelf processor not enough to cater the need of the algorithm. So this gap is widening. This gap is widening. So then how to, like your mobile phone, best example is mobile phone. Tomorrow they'll say, I'm expecting my MATLAB should be, my LabVIEW should be run on the mobile phone. That's it. So my algorithmic complexity is increasing, my demand is increasing, but my processor is not enough to handle such kind of complex thing. So this gap is increasing day by day. To cater this delta, to cater this need, we should have to find some content-based solution. That's why the distributed processing is another way to go. Not only single microcontroller, even mobile phone should have at least 3-4 microcontrollers, and who can handle the applications, who can handle the requirements parallelly. So the progress is made over the years in two domains, computing domain and technology domain. And if you see the computing domain, microcontrollers, digital processors, ARM core chips, and network processors. Nowadays, 5 years before, the network processors are very popular and they are going to suitable for the IoT applications. So what I talk about these slides, this is the embedded systems means what? Why embedded systems are very special, and as embedded design engineers, what care we should be taken for the design in the embedded processors. So, microcontrollers are whether it's an IoT application or not any applications where microcontrollers are dominant player, and every application the microcontrollers are get used, and these are the general very famous manufacturers. Those are very dominant in this embedded area. Atmel, Microchip. Atmel is now taken over by Microchip, Renesas, Analog Device, Texas, ST Microcontroller, Freescale, and many, many more. But imagine why all the manufacturers are sustained in the market. Everybody is selling their product, everybody is at the equal level and earning the money because every manufacturer has the specialty. If you ask me what is the specialty of Texas Instrument, the Texas Instruments are manufacturing the microcontroller. Those are very special in nature. Designers should know when to go for Texas. This is my application. I directly go for Texas because I know the specialty of the Texas. Designers should know when to go for ST microcontroller. Designers should know when to go for Freescale analog device. Once the moment you reach to this level, probably you are the best designer because now you have studied the market, you have studied the manufacturers, the specialty, the what way they are designing the microcontrollers. That's why the meaning of to show this slide is to that we should not be at random choose. I want to work on microchip. Let's say peak microcontroller work on the peak microcontroller. Why should go for peak? What is the specialty of the peak microcontroller and when to go for the peak microcontroller? So the answer should be no, everyone. And these are the requirements for any microcontroller you choose. The microcontroller is expected or the embedded system is expected like sensing the environment, inputting the data, producing a response, outputting some data. Response may be delayed. There should be some timers, counter kind of functions. Prioritize the response, then of course interrupts should be there. Interrupt capacity, interrupt handling should be there. Communicating to the external world, there must be serial communication, parallel communication. See, wireless communication is not a fundamental communication. It's on the top of your serial communication. So basic two communications are there, serial and parallel. Then software to control the processes, non-volatile memory, flash memory, RAM memory, SD-RAM. Temporary data, maybe E square P ROM. So these are the requirements for the microcontroller. What you should be look for microcontroller, and microcontrollers are differ. Microcontrollers are characterized based on how many input outputs it handles, how many timer counters it has, how many number of bits of timer counters, how many interrupt handling capacity a particular microcontroller has, how many serial ports, how many parallel ports, whether USB is there. These are the way the microcontrollers are differ. So then what are the criteria you should be decide to choose for the microcontroller? So what is the peripheral support your microcontroller is having? Can a microcontroller directly interface CAN bus? Can it directly interface USB? Can I directly interface SD card? Then programmability, reprogrammability. How many times I can reprogram the microcontroller? Some microcontrollers are OTP versions, like one-time programming. Some microcontrollers have a flash memory, you can go for millions of time reprogram. So the programmability, reprogrammability, how much memory support it can be. Today I design one application. Tomorrow the same me can I add 10 features. If I am adding 10 features, whether my memory support is still available, or I should go for another series of microcontrollers, then probably that product will be absolute. So see that your Samsung phone has one series. You say maximum is 32 MB. Well, you could go for 64. Otherwise, I have to buy another phone because that microcontroller support that much of memory. So memory support. Physical packing, that is equally important. Then of course architecture. Microcontroller has whether one human architecture, VLSI, VLIW architecture, which architecture, how architecture, which architecture support it has. And most important is development tools. Power consumption, this factor will become when you are going to design a handheld kind of instruments like your digital watch, where power consumption is a paramount importance. But if you are designing one wall mount temperature display, that wall mount temperature display may not be a battery operated, maybe the 230 volt AC supply, where power is not an important factor. So, but my variable device where power is an important factor, then I should think of to choose a microcontroller which is a nanoampere current consumption. So the power consumption is important. And finally comes to the cost. Everything I want, but should be the lower cost. Of course, that will be eventually goes to the lower cost of my product, and my customer will be happy if I'm given the low cost. The best example I tell you why the cost is important factor. There are 100 TV manufacturing companies. All the TV functions in the same way. TV's function is the same, but why there are 100 companies? Everybody is thinking of why should not we add more features with the lower on the cost of the product. And that's the way the people is coming in the market. So 10 more features, 1,000 rupees low cost, 10,000 rupees low cost. Well, then people will be think of to buy that TV. People will think to buy that mobile phone. But as a consumer is a different approach. But designer approach is lower down the cost, adding more features. So then you should be look for particular families of microcontroller for the support point of view. Because if you are writing a program, let's say you have chosen one environment of writing the program, that particular environment ID is not for a particular microcontroller, it's for the family of the microcontroller. And I should be aware about which are the microcontrollers, define the family. So the family is defined as a group of products that share the some basic internal architecture. So code compatible. I'm writing the code for, let's say, PEAK 18 series microcontroller. And if you are going for PEAK 24 series, PEAK 33 series, the same code is going to work because it belongs to the same family. Similar way for Texas microcontroller, if I'm using for Texas MSP 430, if you write a code for MSP 430, more or less same code is going to work for Texas another microcontroller. If I'm using the same code composer studio, CCS environment, and it's from the same family. So this is the beauty of the family. So manufacturer usually define architecture and then make variants of that design, producing a family of the products. And code written for a member of the family should be compatible with all other members of the same family. Now, what other families are there? So this is the Intel 51 family, Microchip PEAK family. This is the ATMEL AVR family. This is the ARM family. These are the four very well-known and famous families of microcontroller. 51 family is a 8051 kind of, or maybe the ADMUC 812. This is analog device microcontroller. So this is 51 family. Microchip family, this is a very popular family. All the microchip family, microchip is a sole chip product is not manufactured by any other company, but Intel family, Intel is not manufacturing. There are all other vendors are manufacturing the microcontroller based on the Intel microcontroller. Like Atmel, AVR, your Arduino, and all these things are from the AVR family. And this is the ARM family. Okay, so Raspberry Pi and your BeagleBone. This comes from the ARM family. So generally, ARM family has some high-end support for the IoT and touchscreen kind of application. So think of the microcontroller was what you are going to be choose for your product development. Even though some additional features are there, you should be think of choosing the same microcontroller from the same family, so that you should not be faced a lot of problems while porting the code for the another microcontroller. So of course, choice is yours. Choice is designers. Which microcontroller should we choose, and which family should we go, which development tools to be used. Now coming to the Internet of Things, so one point is very clear now that choosing the microcontroller, appropriate microcontroller for an application is very paramount importance. Is very important. And once you come that, now I want to design some IoT application. Then what I should be look for? Which microcontroller I should be look for IoT application? Before going to that, first of all, let us understand what exactly the IoT means. What is your definition of IoT? So Internet of Things, if you see this Venn diagram, so this is one of the diagram, maybe taken from some Google source. You see that there are certain things where network capability of your embedded device has the network capability, has some web services are running, because not only network capability is enough. There should be have some web services, because you should be communicate with your cloud. You should be communicate with your all the web applications. Should have some intelligence, of course, and of course it is smart device. So this is the requirement of if you see all these circles together, then there is a cross section of every circles comes to the as an IoT application. Yeah. So then IoT system, if you see there is a one journal IEEE transaction of the IoT, where from there is a specific definition is given, like IoT system is a network of networks where typically massive number of objects, things, sensors or devices are connected through communications and information infrastructure to provide value added services. It's not only the meaning of communicating or connecting, but it should be provide some value added service via intelligent data processing. See that what is included in IoT? IoT included the smart device, of course, embedded device, massive number of objects, things, sensors. So sensor interfacing comes, communication comes, then intelligent data processing also comes. So whatever data is there, because web applications are running, so producing data to the cloud information, then data processing, data analytics also comes, and management of different applications. So everything combined together, that you can call the IoT application. So if you talk to me, the data analytics, machine learning, embedded systems, all combined together, that will become your IoT application. So all these things are part of your IoT application. So like the smart cities, smart grid, home, smart transportation, smart shopping. These all are the examples of IoT. And in everywhere, embedded system is the core of your IoT application. So if you have, let's say, Raspberry Pi phone where you can transfer the wireless and Wi-Fi, that could not become directly the IoT application. You should have many things to be port, like web application to be port, intelligence to be port, your data analytics should be there. So once you add up all these things, then only then you can say it's a true IoT application. So what are the facts about the IoT comes in 2008, the number of things connected to the internet was greater than people living on the earth. Everybody wants to communicate via internet. Everybody wants to be connect via internet. Then in 2008, the number of things, so 2008 means almost 10 years before, 10, 12 years before, number of things connected to the internet was greater than the people living on the earth. Then huge traffic. These are posing challenges in another areas. Then you came to know which are the another and most prominent area is coming emerging in picture because of this thing. IoT, everybody wants IoT, then it poses challenge on some other things. In 2020, it is expected that the number of things connected to the internet will be about 15 billions. So is going to be increased a lot. And the Gartner report, Gartner is a very famous report. Gartner forecast in 2020, it is expected the entire business of IoT will go to the $300 billion. So imagine this is the fact and figures. It is published in the Gartner forecasting report, IDC and Gartner report. So if you see for architecture of IoT, the 4-stage IoT architecture is there. Of course, sensors and actuators are already there. On top of that, conventional embedded application don't have integrated gateways, but here you must require integrated gateways, data acquisition system, as well as network and IT infrastructure. The conventional application, not necessary, like what is the application I have shown you, not necessary there is a network and IT infrastructure is required. Like wire bonding machine, where is the network gateway? Where is the network and IT infrastructure is not required. Data center and cloud. Once you have web application is running, you are transferring your data over the cloud. Of course, you require data center, like Amazon data center, Amazon cloud. So that becomes the part of your IoT applications. You see, Amazon is the best example of IoT, I could say. You are picking your product, you are placing your order. You don't know what happened in the back end. There are a lot of supply management and supply chain, and even all embedded applications are there. Eventually, that complete product it comes to be as IoT. Data analytics is there, data security is there, machine learning is there. So many things are involved in that application. And then after 2-3 days, you find, yes, my product is delivered at my home, but how many people, how many intelligent systems have worked behind that? So that is one of the best example of IoT, I could say. So data analytics and data security. That's why these two areas are becoming more popular nowadays. Because of that, everybody wants to connect on internet. Everybody wants that application. When billions of people are pushing a data, huge amount of data is available now on the internet. What to do with this data? Of course, data security issue starts. People are now just stealing your data and they're playing with your data. So once your data, like Google, everybody has surrendered whole life to the Google, starting from your Gmail, starting from your Facebook and all these things. So all data is available. Even your family doesn't know about you, Google knows about you. Google is more smarter than your family members because you just have put everything to the Google. All data is available with the Google. Google knows what you are going to do in the next 5 days. I'm 100% sure everybody sitting in the class, every person's personal information is live with the Google. And Google knows that XYZ, what they are going to do in the next 5 days, where they are going to shop for next 5 days, where they are going to travel for next 5 days. You will get pop-up windows in your email. Hey, you want to travel, then these are the options. You'll be surprised how I'm getting such kind of emails. I don't know how I'm getting such kind of emails. I have planned my travel for next 5-10 days, and then a lot of options are available. Of course, you are going to pick one out of that. This is called as IoT. This is called as digital marketing. So this is the IoT architecture, IoT solutions for this, like Internet of Things, everywhere, like wearable technology, all your digital watch, everything is connected now. The smartphones, vehicles are connected, home lighting, home applications, your personal computer, your aeroplane. Even aeroplane also you find the internet is available, online shopping. So such kind of, these all are become the IoT applications of today. So this is wearable devices, smart home, healthcare, smart cities, agriculture, smart grid, retail business shopping, industrial automation. Everywhere you find there's IoTs involved and IoT applications are there. Connected cars, this is the concept. This is new for the Indian scenario, but this is not a new for the Western culture. So connected cars. Every car has the IoT devices. once you start driving from, let's say, one X place to the Y place, your car is tracked fully. And suppose you purchased a car from BMW, like Mercedes or some other companies, then they knows each and every car, they monitor each and every car, the performance. Even they are connected to the nearest garage, and when you're traveling, immediately next 5 minutes, if you have some problem, the help is coming next 5 minutes. Even they have one screen, inside that they pop up where are the your food centers are available, where are the medical facilities are available. So this is just possible because of your car is connected and it is get tracked by some of the devices. Like this is an example of wearable devices, you could say heart rate monitors and glucose monitors. This is the example of smart agriculture. Agriculture also becoming smart nowadays. I just want to switch off my pump. This is only small reason, but for that I'm living 10 kilometers away from my farm. Just to switch off my pump, I should go to the 10 kilometer. I will get signal on my mobile phone. Okay, my farm is now get filled with the sufficient water. I just press the button. App is there of my farm. I'll just press the button from my mobile phone. Just switch off that pump. This is not difficult, and this is already there. Such kind of products are already there. So, usage of such kind of techniques for the agriculture is and people are using for that. So not necessary that your farmer should be intelligent enough. As he's using mobile phone, ready infrastructure, he just have to open that app and you just play with the mobile and see what is the status of my farm. Even your greenhouse, all the statuses get monitored on your mobile phone. What is temperature inside it? What is humidity inside it? So this is where the smartphone is becoming more important for this. Smart grid is another example of smart grid, like why people are going for the solar and they're generating the power. You see the why smart grid IoT had changed the life of human beings. 10 years before, a lot of shortage of electricity. Days and days there is a blackout. Days and days there is a electricity shortage. What happens exactly? Today, surplus electricity. Whether we have increased electricity generation, no, electricity generation is that much only, but because of addition of smart devices, the excess power I could able to handle properly, I could able to put on the grid where the requirement is there, and that requirement is managed smartly. That's why there is no wastage of electricity. Just wastage has saved and wastage has used proper way. Electricity is surplus now. So this is the best example of IoT, I could say. Industrial automation, Industry 4.0. So factory digitization, factory product flow management, safety and data security, inventory management, quality control. So these are the applications in Industry 4.0 where IoT is useful. Healthcare. So IoT in healthcare is aimed at empowering the people to live a better life. And if you ask me, what is the future of IoT in India? The future of IoT in India is a healthcare. Next five years down the line, next 10 years down the line, a lot of innovation is going to be happen in this area, healthcare application. So if somebody wants to work, somebody wants to be think of becoming entrepreneur, think of working in this area, the IoT in healthcare, and that will be the very emerging area in next 5 years, 10 years down the line. There is a small video is there. This is because of time constraint. I'm not going to play that video. How the IoT, because of the IoT, how the medical facility, emergency medical facility is provided very quickly, and how we can save the life of the person. Like if you're driving to the car, and if your car is IoT connected, and if you have some accident, immediately that data is get transferred to the nearest cloud center, and in next 5 minutes, 10 minutes, ambulance will be there available to your car, and you could take to the hospital, nearest hospital. And if hospital and that ambulance also connected, the hospital knows that particular ambulance is coming. They should be ready with all the facilities of emergency facilities, and you will get medication very quickly. Nowadays, it is not connected. Ambulance has started from one location, but don't know hospital ambulance is coming. When ambulance comes, then they start preparing the things. If there is a massive heart attack of the person, probably he will not be alive. So these are the things. This is the advantage of connected things. Again, smart cities. The best example is nowadays the smart cities are there. So IoT enabled microcontrollers. Now you see the IoT and the IoT examples. The microcontroller, those are part of this IoT application. Then which are the microcontrollers generally get used? So there are off-the-shelf embedded processors are available, embedded microcontrollers are available in the market. Those are IoT enabled. Some IoT development boards are like this is one board called a chip, CHIP. You can search on Google. I have given here Google website as well. It's the first $9 computer. It comes with powerful 1 GHz processor powered by all with R8. Bluetooth compatible. It has Wi-Fi radios and always providing the out-of-box connectivity. 4 GB memory with the Debian, Linux Debian is running with 8 GPIO pins. It has PWM, UART and I2C everything. So this is a picture of that board. It's a $9 processor, $9 board only. So you can think of, suppose somebody wants to work in this area, try to order these boards. It's very, very affordable and it's very easy to use for this. Another one is a MediaTek Linkit one. This is another board, but this is little bit expensive. Price is $60. This is again Arduino compatible, which uses the Arduino IDE. The chipset is ARM7 260 MHz clock, which is MT2520. Of course, it is a GPS, GSM, GPRS, Wi-Fi, Bluetooth compatible. All these wireless connectivities are available with this board. If you want to develop the application where your requirement is GPRS, GSM, and Wi-Fi, Bluetooth, probably you can think of working with this board. This is another board. It is called the particle photon board. Of course, this is also used for IoT. This is $20 board. It comes with a Broadcom processor. The Broadcom generally this is very famous processor in the mobile phones. It's a Wi-Fi chip. STM32 architecture, 125 MHz clock, and is an ARM Cortex M3 architecture. 1 MB flash is there. Comes with 5 analog chips and analog pins and 8 digital pins. So easily portable Android app on this one. Please try out this board as well. It's called a particle photon. This is another board called as Adafruit Flora. So it comes with the popular Arduino microcontroller and it supports Arduino IDE. It's based on Atmega32 microcontroller, Atmega32 and Leonardo operating system. So supports micro USB and NeoPixel LEDs for easy programming. NeoPixel LEDs for the status indication, which supports the micro USB for the program. This is another board, light blue bin. This is the Arduino compatible microcontroller board. It has a low energy Bluetooth, temperature sensor and accelerometer. It has accelerometer as well. Atmega32 architecture, 32 KB flash, 2 KB SRAM. This is bin. This is called as a bin processor, a light blue bin. And this is Neo board, Udo Neo. This is called as Udo Neo. This is $70 board. It's again Arduino compatible. It is a combination of Raspberry Pi and Arduino. It has same pinout as Arduino. It has 2 cores, 1 GHz ARM Cortex A9, ARM Cortex M4, 200 MHz. Wi-Fi and Bluetooth and basically it's a USB support, not GSB, USB support. It supports the Android Lollipop and customized Debian. Again, this is another board, Intel. It is Arduino and Raspberry Pi, of course. Both are the Arduino, it's a Atmega32 architecture and Raspberry Pi. And this is ESP32 development kit. This is also very famous. That's called the ESP32 processor. It is based on ESP32 SoC, 32-bit CPU, 240 MHz clock, and it has Wi-Fi and Bluetooth connectivity. See, the intention to show you all these boards and development boards is that people should be aware about. Let's say I want to work on IoT, then I should not be choose any microcontroller, I should not be choose any processor. Rather, I should be go for choosing their processor, the embedded processor. Those are really available in the market, which has inbuilt IoT compatibility, so that your application will be developed very fast and you can plug in your application. And so if you see for now future, what is IoT future? So by 2025, it is estimated that there will be more than 21 billion IoT devices by 2025. This is expectations. Cyber criminals will continue to use IoT devices to facilitate DDoS, distributed denial of service attacks. Now, the cyber criminals, they will attack your data. They will try to steal your data because now data is available in open source, data is available on the web. So more cities will become smart. Of course, the development of IoT devices, it's become very easy. You can see that when I'm going to get the corporation water and how much water I get consumed, what could be my next bill, even you can control your home. So even you see now I'm standing at the bus stop for next 5 minutes, which bus will become and where the bus is right now. So all these, once it is get connected, then this data is very easy to take it on your phone. Artificial intelligence and machine learning will continue to become bigger things in IoT, with data analytics will attract more jobs in future. Why artificial intelligence and machine learning is becoming popular? Why data analytics is becoming popular? Because of just expansion of IoT architecture, expansion of IoT devices. That generating more job for the data analytics, that generating more for artificial intelligence and machine learning. Routers will continue to become more smarter and secure. 5G network will continue to fuel IoT growth. Now there is a limitation of 4G because of more number of devices get connected. Now your bandwidth is now reducing. There is a need to go for the 5G network. And of course, 1 year, 2 year down the line, 5G network will become in the market. That will be give them more speed for your, and you can have the access to create the more IoT devices. Your cars will be get even more smarter and connected. Of course, you should be think of connected cars kind of thing. And if your car is not connected, then you can say you're disconnected person from the world. So imagine if you have the car, then car should be connected. It should be connected car. Network security and privacy concern will drive legislation and regulatory activities and will be the future of employment. You see, there is a laws will become, cyber security laws will become, and again there will be future of employment. There is opportunity of employment in the cyber laws and cyber securities. Even so, network security and privacy concern, that kind of laws is enforced to be added in your laws, and that will be again probably the one area of employment. So this is the IoT and where the IoT future will be lies and where the employment opportunities will be get created. So that's it from my side. So thank you for your time and patient listening. Now there are still 10 minutes to go. If you have any queries, happy to answer.
If anyone want to ask any question, then he or she can write in the chat box.
Or you can, Naman, you can unmute to a particular person.
Okay, okay, sir. Okay, yeah. So now anyone can unmute himself or herself to ask any question if one wants to ask.
I will be very happy. I will try to give answer of your question if you have any specific question. In between, my audio was not clear. Dr. Vasudha, Madam Vasudha.
Sir, some background noise was coming, sir. That's why I mentioned audio was not clear.
Oh, okay, okay. Now is it clear?
Yeah, sir. Now it is clear, sir. Apart from
Yeah, okay,
noise,
please.
some other noise was there, sir.
Yeah, I'm sorry for this. If you have any specific question, please let me know.
No, sir. Understood the topic.
Anyway, I'm going to share this presentation to the organizer. So organizer will circulate this presentation to everyone.
Thank you, sir.
So thank you very much, sir. Thank you very much. I hope anyone is not having any questions. So if there will be any, then I will definitely circulate to you. And then we
Sure,
have one another session with you, sir. So in that session, we will you can just answer those queries, sir.
sure. No
So
problem.
thank you very much, sir, for giving in brief about embedded system and embedded system related to IoT. So it will give a suggestion or a way to the participants to work in the field of IoT. It will be definitely helpful to them. So thank you very much, sir.
Thank you for giving me opportunity to talk in front of this August gathering, Naman. Thank you, organizers, and I'll be very happy to answer your queries. If you have further, please do email me or do email to organizer. They will pass to me. And I hope most of you should be get motivated to work in this area. There's a lot of opportunities in this area, and the field is open for you.
Definitely, sir.
Thank you.
Thank you. Thank you very much, sir.
Thank you.
So all the participants, the next session is from 2 onwards. So till then, you may leave the meeting, and at 2 p.m. onwards, we will have second session for today's. So till then, have a great day. Bye. Thank you, sir.
Thank you.
very
Thank
much.
you, Raman. Thank you. Should I leave?
Yes, sir. Yes, sir. You may, sir.